Okay. So sorry for interrupting. You can continue, Karthik. You were asking something? Hello, Karthik.
Apology, I was talking on mute. Sorry, I was talking on mute.
Yes, yes, you were telling something, right? Tell me.
Yeah, sorry. Is there a recording for search classes which I can see, which I've?
Yes, yes, yes. You can go to the Swam app, like software rather. So you can go over there. There are the 5 classes that sir have taught. You can, not a problem. If you have any doubt in anywhere sir have taught, you can ask me in the next session. I'll have
Okay.
same time like every week. Right.
Yeah, sure. Thank you.
Okay.
Thank you.
Okay.
Yeah,
Okay.
the recorded ones which are available for public, that's what you're referring to, right?
When you will
For
go to Swam
IIT,
app, like let me share you and give you the, like, you know how to operate that app, right?
I go to all courses. That's what you're referring to.
Yes, all courses over there. You will go to the fluid mechanics course, and over there you can see that week zero, week one. Over week one, you can get all the 5 classes that are already done.
Okay, got it. Yeah, it's
Okay.
there in the NPTEL one. Yeah, understood.
Yes, that's why I'm app. Yes. Okay. Okay. Thank you.
Thank you. Thank you. Sorry.
Yes, yes, yes. Not a problem. So, in like there is very interesting phenomena like that we can do with the mechanics, like fluid mechanics rather. So even the work in the work we do, we design like simple kits that will be used as a for detection of different biomarkers. Like if like you already know the pregnancy test kit, right? Hello, pregnancy test kit, then glucometer. You already know about that.
Yes, ma'am.
It works on the
Yes.
that is called lateral flow assay. It does work on the simple phenomena of flow of fluids. So there'll be some certain color develop or certain electrochemical signals that will be generated. Simple, like in our blood, in glucometer, what does it do? It check the concentration of glucose that is present in one's blood, right? And even on sweat sample or something like that, right? In saliva samples. So what it will do, will just let the flow, let the analyte means sweat sample or blood sample or blood serum, plasma samples, anything. So our body like fluids. So the surface fluids that we have in our body, we'll just let it flow over that device, and based on the concentration of glucose that is present on that sample, we'll get a certain color, and that color will give in turn give us the identification of how much the concentration of that glucose is present. So the pregnancy test kit work on the same way. There are some antibodies, like I won't go too much details, but this works on simple basic understanding of fluid mechanics. So, as I've already said, the fluid mechanics have been used on like it is branch of physics only. So it is governing like various applications, like even like the surface tension, like a drop of fluid is there. So any one of you know about hydrophobic or hydrophilic surface? Any idea?
No, ma'am. Sorry, I'm totally new to physics, ma'am.
Water
No.
loving and water heating
Yes,
surfaces. Is it
correct,
correct?
correct, correct. Okay, so hydrophilic, as the name suggests, it is a water-loving surface, and hydrophobic surface is water-hating surface. Simple, like in like uh, lotus leaves. So that is a super hydrophobic surface. What is happening when you will be putting one drop on that surface? It will be just rolling down. Is it? Have anyone seen that natural phenomenon?
Yes.
Yes. So that is a super hydrophobic surface. Like it is highly hydrophobic to water. So all these phenomena are being governed by the basic fluid mechanics only. Like there will be some minute structures, and as sir have taught in your class also, like if like let me draw and show you. In lotus leaf, see some structures like this are present, right? And or you can even represent like this. So there will be some air trapped over here. because the surface is superhydrophobic and there are minute particles, like minute, sorry, not particles, hierarchical structures, rather structures on the surface. So there will be air trapped here, and because of which, if we will place one water drop over here, so when we will just tilt the surface, it will just fall off, right? So this is a application, like this is one of the application of a surface, like various researcher work on the modification of any surface, right? Like self cleaning glass, have you heard about it? Based on this lotus leaf application on, like phenomenon, have you heard?
Yes, ma'am. And even some
No, ma'am.
clothes are developed.
Yes, clothes are also developed, super hydrophobic clothes, where it won't get wet. So you can search this interesting phenomena in YouTube also. Super hydrophobic surface, you type super hydrophobic surface. Let me write it down. Super hydrophobic, right? Or rather hydrophobic surface. The surface that will hate water. So it will just try to push it off. So all these such interesting physical phenomena are based on simple understanding of fluid mechanics. So I hope you understand how like fluid mechanics is affecting our life. So in every field it have application. Like biology also I've given one application to you. Like there will be some channels like there will be this kind of channel developed, like cell sorting. For cell sorting it is used. Like the let's suppose when a cancer cell is there, so cancer cell, it will do, it will be lumps, in lumps. So what will happen, the size of a cancer cell will be larger as compared to a normal cell. So if size will be larger, what will be happening, the centrifugal force on this will be large, and if the centrifugal force on this is large, so it will be on the sides of this channel, right? Have you heard about the channel, the fabrication of channels?
Yes, ma'am.
So yeah, so if we will be fabricating one this on PDMS channel, one this kind of shape of channels, right? This will be the outlet, this will be the inlet. So what will happen, the heavier particles will be at side and the lighter particles will be in this side, right? Because of the centrifugal force on the heavier particles will be more as compared to the lighter particles. So in this way we can sort the both of the cells. Like if we will keep two openings here, one from inner portion, one from the outer portion, we can separate both of the cells. So there you can see how much application is there for this fluid. So I think I can develop a basic interest of this subject, right? So let us go to the next slide now. Okay. So I think you have already covered, sir, like one who have not, Karthik have not covered the class, but I think I can give you a brief understanding of what is happening. So there are two viewpoints of understanding of fluid rather. Okay, so as sir have taught in class, as this image you see here, so you can see that there are different like if we take a gas into consideration, mm, there will be different particles of gas, like let's suppose molecules of gas over here. So we can see that if there are large number of gas particles, and let's suppose if you want to measure pressure of that gas, so there may be two approaches. Like we can take a microscopic approach and another is a macroscopic approach. So what is happening in microscopic approach? We will take into consideration each of the particles that is present over that space, right? That the space that we have selected. And for macroscopic approach, we can take a particular section, like here they have selected one volume, right? So that volume we can take into consideration, and over that volume we can take a gross value of pressure. So why to go in that particle approach? Like if there are large number of particles on that specific section, we cannot track each and every particle, and that particle will come inside of that section. Like let me draw it out to make it simple for you. So if there are large number of particles over here, Anyone wants to speak anything up?
Yeah, sorry, is it more like a sampling when it comes to macroscopic approach?
Sampling in the sense like we will take a gross area and we will focus on that area itself. How many particles comes in or goes out, we don't care actually. We will just
Okay.
take that area into consideration, like volume
Okay.
rather. Okay, so if there are a lot of particle over there and we want to take this area into consideration, so if we will do the particle approach, then this particle, like if like let me use some other color. Okay. Okay, it's not working right now, let's see. Okay, see, what is happening? Okay, leave it. So let us suppose this area or volume we are taking into consideration. So if I take this particle, this specific particle into consideration or molecule of gas, this, as gas is so random, this molecule will be here and on the next second it may not be here, it may go here. So if we will do the particle approach, it is very difficult to track each and every particle over there. So that's why we, for like we want to measure the pressure over here, so we will not take the individual particle approach, we will rather go for whole volume and we'll see how many like what is the pressure of that, gross pressure of that volume. So this is called macroscopic approach. Okay, so there will be like some system like a rarified system, as I've already noted here, or if the volume is very small, like as I already said, in micro scale or nano scale, volume is very small and very few particles will be there present. So over that, we won't be able to apply this continuum hypothesis. That is, we cannot go for that macroscopic approach, right? In macroscopic errors, like what is the continuum hypothesis, we have already seen in class. It is like over this like whole section, this whole volume, we will assume that like there is particles every in each and every point. Like we will like assume that there is continuous particles present in the whole section. So this is the continuum hypothesis, that is there is no vacant spaces over there, right? We will assume that. But if the system is rarefied, means there like in that section like one or two or four particles are there, so how can you consider that these continuum hypothesis, because there are lots of vacant spaces. So in that case, or in case where the volume is like very small, so like if in micro scale or nano scale, over there we won't be able to like use this macroscope, sorry, continuum hypothesis. So on what basis would we decide whether this continuum hypothesis is valid or not? So this will be given by Knudsen number. So I won't be like giving much detail of this. So Knudsen number basically will give like it is the okay, I'll give a detail of this later because we have a question based on that. So whoever have attended the class, you can answer that and then I'll give a definition of this. Okay, so let me go to the first question. So this is the first question. Okay, so what does it say? Based on the previous concept, I've already given you the macroscopic or microscopic approach concept and the continuum hypothesis. So which of the following statement is or are correct regarding continuum hypothesis?
Ma'am,
Yes, tell me.
screen screen is not visible for me.
Not visible for everyone, it is the same.
No, ma'am, it is visible for me.
I can see. I can see.
You can yes, you can go for the participant section and
No,
over
like
there.
oh, the questions what you are saying, I can't see that
Yes,
question.
yes, yes, you can go for the participant section, like in the Google Meet there is right side down corner. You can see the participant section, like the participants, 9 participants are there. You can see that, right?
Yes, ma'am.
So you can open that up and then you can see that I am presenting here, meeting host, and it is present, their presentation is there, your presentation, kind of. Like I'll be presenting something. Have you seen that?
Yes, ma'am.
Okay, so there'll be 3 dots over there. So you can pin that. There'll be one option called pin. Have you found that?
Yes, ma'am.
Okay, so you can pin my question, like the presentation section. So over there, you will see that, yes, the questions are visible. Is it okay?
Okay.
Okay. So what will be the answer of this? Can anyone answer? Like I've already told you, still.
Option B.
Yes. So it will be option B. And another option is there. Tell me which one. There is or are. Anyone can tell me? Along with option B, another one is correct.
C1.
Yes, yes, correct. So this is option B and C, and why I have already explained. So let me go to the next question. That will be based on Knudsen number. Yeah. So Knudsen number, I have given you a bit detail, like what is Knudsen number, and that will be helping us to determine whether the continuum hypothesis is applicable or not. Is it? So can you tell me, like, which of the option is correct?
Tell me. Yes.
A option. A option.
Yeah, yeah, correct, correct. So Knudsen number, for those who have not attended the class, is it will give an idea of like, is the continuum hypothesis valid or not? So Knudsen number is basically given as lambda upon L. Lambda, what is this lambda? This is mean free path, right? And L is the length scale, characteristic length scale of a object that is into consideration. So what is mean free path? Like, let's suppose this is a section of fluid, and this is an object and there is another object here. So they are in, like, if it is a gas, they're in random motion. This will be Brownian motion, like this. It will be moving here and there. So if it will come here, if this second object is very closely placed to the first object, then it will be immediately colliding to this, right? So what will happen, this collision, like the distance this one has traveled before colliding to two, that is given by, that is denoted as this lambda, mean free path before collision, right? So if it is a densely packed system, like in case of a gas, if it is a densely packed system, then it will be immediately, like, particle 1 will be immediately colliding with particle 2. But if it is rarefied system, like one particle is here, one particle is here, then it will travel like this, and then it will be colliding. So at that point of time, this lambda will be very large, right? So it will be depending upon the characteristic length of the system. So if it is a micro system, this characteristic length will be in microns. So if it is in microns, so that is some micrometer, like let's suppose 10 micrometer. So at that point of time, this will be like, just one second, I'll just change the screen. Yeah. So at that point of time, this L is so small that it will be immediately coinciding with immediately coinciding with this. So at that point of time, like when this lambda is small, in that point, this continuum hypothesis is applicable. Is applicable. So this is given by lambda by L. That means if lambda is far greater than L, that means continuum hypothesis is not valid. And if lambda is far less than L, that means it is like immediately colliding, then the system is not rarified, nor it is like the length scale is very small. At that time, it is valid. So any question in that?
No, ma'am.
Okay. So this just Knudsen number gives us an idea of like, in case if this is a pipe. So sir, I've already taught you in the class, like in case of pipe, the fluid boundary layer will be like this. This we will already like study in the later classes. So this is the boundary layer development. That is the velocity at wall because of no slip condition, it is at rest. That means if this, sorry, that means if this wall is at rest, then the fluid particle that is present here will also be at rest, right? And if this wall is in motion, let's suppose it is moving at a velocity of v, then this fluid particle will also be in motion. This is the concept of no slip. So this, this wall, like this the particle like, or the fluid particle that is at the wall will be at rest, and as it will move to the center of the tube, the velocity will continuously increase. And so this up to this radius, the change of this velocity will take place. So thus the characteristic length is r here. But as sir told, in case of like engineering applications, we take it 2r. But actually the velocity is like for simplifying this, we are taking this 2r. So in case of pipe, the characteristic length is 2r, and depending upon lambda is greater than or lambda is less than 2r, this continuum hypothesis will be valid or not valid, right? So let us proceed to the next question now. Okay, so okay, so let me just 1 second. So I've already told you the particle approach and the taking one whole section into approach. So if you have taken the classes, so you will be able to like, you will be knowing that like which one is Lagrangian approach and which one is Eulerian approach. So just give me the answer of this question first.
A and B.
A and B, like A and B both is Lagrangian
B,
approach.
B. No. A and B, B.
Yeah, correct. We in like when we will tracking each and every fluid particle, then it is a Lagrangian approach. And we when we will
Lagrangian.
yes, and like in case of pressure, like we are taking a whole bulk into consideration, that is the
Oh,
pressure,
yes.
yes, the pressure that is provided by all the particles, gas particles on that specific volume. Like how the pressure is determined, it is determined by the force that is that all the gas particles is given. Yes, will be ready in week 1 and week 2 and join next week. Let's some preparation. No, it's not required. You can continue with the class. And if you don't understand anything, Karthik, so you can ask me out. Not a problem. So I'm explaining you from the basics on everything. So not a problem. Okay, so in case of like what I was saying, yes. So in case of Eulerian approach, we'll be taking whole bulk, as I've already told you, whole bulk into consideration. So if we are taking like this a bucket, like a bucket is there and it is closed and a gas is trapped inside. So this gas is providing some pressure in the walls of this bucket, right? So this is taken up by as a bulk approach, right? That how much force is provided per unit area by that gas on the walls of that bucket will be giving us pressure. So this is a bulk phenomena. So that is given by the Eulerian approach. I hope you understood. Any questions? Any question, please?
No, ma'am. Understood.
Okay, then. Let us proceed to the next question. Excuse me. So, which among the following correct mathematical form of angular momentum principle for fluid flow in the absence of body couples? Okay, so we have seen the Cauchy's theorem, like sir have taught that in the class. Should I go to a brief detail if you want to know, like a
Ma'am,
derivation?
option C is the correct.
Yes. So, for just 1 second. Abhijit, you are so late in class, like almost it will be getting over in 1 hour. Okay, late. So it's okay, just attend. So okay. Now, according to Cauchy's theorem, like if we will be like let me go to the derivation only. Then it will be like for those who have not attended such sessions, they'll give a brief idea of that. So how we are deriving? So if we will be taking a 2D section, so in this 2D section, like it is not 2D actually, the Z axis, like this is Y axis and this is X axis, and the Z axis is perpendicular to that screen, right? So if we will take this is delta Y, and let's suppose this is delta X. So this the you know about that stresses, right, on each and every surface that is
Yes. Yes,
that
ma'am.
is
The
present on the surface. Yes,
tensor stress, I think.
yes, correct. So the tensor stress, that is this is simply the pressure basically. So the pressure is a surface phenomena. So in each and every surface, like there'll be pressure that will be exerted on the surface. So on this surface, if I'll take this surface into consideration, the perpendicular, there'll be two stresses that will be applied. The perpendicular stress will be tau 1 1, like 1 1 means this x and x, right? And another will be on this direction. Can you tell me which stress is this, like in this direction?
Tau 1 2.
Yes, correct. Tau 1 2. 1 means like for Karthik, right, who have not attended the class. So tau stress we represent, it is a tensor, like second order tensor. So I hope you know the second order tensor. So this will give the normal to the surface. This will be given by the normal to a surface. Like in this case, in this, like let me choose some other color. So in this case, this surface, so this surface is perpendicular to x, right? So hello, yeah, so normal to this surface will be in the x direction, right? Karthik, have you understood?
Got it, got it. Sorry, I was talking on mute again. Sorry, got it.
Yes, yes. So, so perpendicular to this will be in the x direction. So that will be represented by 1, and x we are taking here as 1. So that's why that is tau 1, and the second, this j, will be given by the force, direction of force, direction of force. So here the direction of force is in this direction, that is in y direction. So that's why it is given as 1 2. Understood?
Got it.
Yes.
It's a 2D plane, right? Okay, sorry.
It
Yeah,
is a
got it.
2D, like we are just considering the 2D forces. So it is not a 2D plane. There will be z axis as well, but we are not like neglecting that for the
Okay,
time
I
being.
was about to ask that. Sorry, I was about to ask that. How do you know that the force is only in that direction it goes?
Hmm. So you understood, right?
Understood. Understood.
Okay. So now in the similar way, there will be forces in this direction. So that will be tau 2 2, and forces in this direction, like this direction. I'll take in different color. Hmm. in this direction. So that will be tau 2 1, right? And in the same way, the normal to this surface, this left surface, this is actually like in the negative direction of x. That's why to compensate for that, we'll be taking shear stress in just the opposite direction to tau like tau 1 2, it will be the opposite of that. So this will be behaving as a couple. So tau 1 2, it will be in downward direction. And another thing is that in this surface, it will be tau 2 2, and in the similar fashion it is in negative y direction, so it will be in opposite direction, right? Opposite direction of y. So sorry, x. So it will be tau 2 1. Any doubt?
Yeah.
Okay. So there are two derivations of Cauchy's. So for this question, we'll be understanding the second kind of derivation, that is taking the moment into consideration. Like if any surface is that, and this is the axis, and this surface is rotating, right? This or surface, or rather volume, anything you consider. So let us consider a surface. So this is rotating. So there will be they for this rotation there will be one moment of rotation that is given as I. So this no, sorry, M. So this moment is given by the forces, like it is denoted by the forces that is applied for that rotation. So basically we are taking rotational forces into consideration, right? So just one sec. Yeah. So let us take all the forces with respect to this axis. Like here we are considering this to be the axis, this one, this about the rotation is taking place about this center O. That means this center O is perpendicular the perpendicular to the the screen, or rather a paper to you. So about this surface, like if this is the plane that we are considering here, the 2D plane, then this is the z axis, and this perpendicular to this z axis, the plane is rotating. That plane is rotating like this. Okay. So if we are taking the resultant of all forces, that is the resultant moment of all forces, so this will be about z axis, because the rotation is taking place about z axis, and this will be the moment of inertia. This we have already seen in our class of physics. This moment, the summation of the moment of the forces will be equal to the moment of inertia multiplied by the acceleration, the angular acceleration for this rotation, like the angle at which it is rotating, the angular acceleration, this will be alpha. I hope you can see where I am writing. Okay, let me use yellow. So this is the alpha, this is the angle of rotation, uh, that is the angular acceleration. Just one second. Yeah. So if we will derive this, then okay. So here tau 1 1, tau 1 1, that means this one, and tau 1 1 on this direction, this will be cancelling each other, and tau 2 2 and minus tau 2 2 will also be cancelling each other. So we won't be writing this. So these are, cause these are equal and opposite, so what we will be writing here will be tau 1 2, and tau 1 2 means this one, right? Tau 1 2, and what will be the area where the shear stress will be applied, that will give the force, because this is the force, right? Force means pressure into area on which it is applied. So here on which surface it is applied, it is applied on this surface. So if we will be considering unity on the z axis, so then it will be, this is delta y, this is delta y into 1, and the moment, like from this surface, like this is behaving as a couple, right? As I've already told you, tau 1 1 on the negative x side, and on the positive x side, like positive x side on this side, and on the negative x side, that is one is opposite to other, so it is behaving as a couple. So we'll take the distance in between them, so that is denoted by delta x, right? Minus for tau 2 1, it will be tau 2 1 uh, tau 2 1 delta x into 1 into delta y. So this will be given by like multiplied by iz, that is the moment of inertia into the acceleration. So moment of inertia is given as the mass into length square. So the length squares are have already derived in class. So that is delta x square plus delta y square, because we are considering 2D surface and in z direction it is unity. So divided by 12. And for the mass will be the total volume del x del y into unity into density. So this is the whole inertia multiplied by alpha. Okay. Multiplied by alpha. So this if we will write like this, so now we want to take the force to the point where the whole rotation is taking place. That means if we consider this to be point O, we want to measure at that point O. That means del x del y will be tending to 0, as sir have already said, because we want to, final aim is like we want to measure the stresses or the force at a point. So so in that point, so we will write del x tends to 0 and del y tends to 0. So if we will apply del x del y tend to 0, this will be negating, and this will also be del x del y and del x del y, this will be cutting off. So what we are getting, this whole right hand side will be 0, and we will get the only the left hand side part. The left hand side part will be tau 1 2 is equal to tau 2 1. So this is the Cauchy's another form. So this in subscript form we can write as tau ij is equal to tau ji, right? So this only will help us reducing the, like if this is the shear stress matrix, tau 1 1, tau 1 2, tau 1 3, tau 2 1, tau 2 2, tau 2 3, tau 3 1, tau 3 2, tau 3 3. If this is the diagonal part, then this tau 1 2, let me use a different color. So tau 1 2 means this one will be equal to tau 2 1. Now tau 1 3 will be is equal to tau 3 1, and another one is tau 2 3 is equal to tau 3 2. That means these six parts are not mutually exclusive. That means this tau 1 is equal to tau 2, so it can be represented as any one of them, and tau 1 3. So we previously had 9 components. Now it is reduced to only 6 components, because this won't be mutually exclusive, so it can be represented as one, right? So
So
uh,
basically, except the diagonals, all others are mutually inclusive.
no, not all others. Yes, like you can say that.
Except the diagonals.
Yes, correct. So
Okay.
diagonals will be considering as 3, plus the other two are not mutually exclusive, so they can be represented as 3. So total there will be 6 independent stress factors, right? Okay, so Karthik, have you understood? I
Yeah,
hope I can
I,
make you
I,
understand.
I got this. There are a few terminologies that we have used because I'm not from the physics background. Apologies on that. I thought it's more of an
Okay.
applied math side, so I thought it would be good.
Like fluid mechanics, as I have given you the introduction, it is basic physics. Everything on this is physics,
Okay.
right? So you have to get a basic idea of, like, you have studied that in class 11 12. I think you can get through that once.
I'm not from the science background. Sorry.
Oh, not in science background then?
I'm from the basic mathematics background, not from the science background.
But for explaining physics you need maths only, right? So these are the
Yeah.
simple
So
things.
that was the one I was trusting on. So I got a lot of jitters now. I'm getting a
No,
lot of
not a
jitters now
problem. This
looking
is
at it.
rotational motion. There was one chapter in class 11 or 12. I don't remember.
I'm
So
not from 11th and 12th science group.
okay, so you can get through that. Not a problem. You can get some basic 11, 12 classes, and within a span of 2 weeks, you can get an understanding of this.
I'll do.
Rotational motion.
Yes, rotational motion. Correct. Thank you for correcting me. Okay, so
Ma'am,
next,
why is the
yeah,
can you tell me why the body couple?
yes.
Ma'am, here is question is saying in the absence of any body couple, but where is the body couple in your presentation?
Body couple means I don't understand here.
Means it's
It is
showing that.
it is the assumption that we are taking, right?
Okay, okay.
So this body couples you have taken the class, right?
Yes.
Over there only, like body couples, we are considering that body couples are not present over there. So that's why we can take we have seen na tau 1 or tau 1 2 on the negative side, and that is tau 1 2 and minus tau 1 2. We are taking as one couple,
Okay, okay.
right? Okay.
Okay.
Now let us proceed to the next question. We'll take like more half an hour, and then we'll be done with today's class. So determine the number of independent stress tensors. I have already explained to you this now. So can you tell me which one is the correct answer?
D1. D.
D.
D. Yes, correct. D. So you have understood this, right? So let's proceed to the next question then. So I've already told you we'll get some basics of your assignment 0. You have some done some matrix issue, like the matrix problems, right? So we'll just get into those problems. So first, let us do some dimensional analysis. So can you tell me which is the dimension of pressure?
C.
Yeah, correct. So can you explain me how it is?
Ma'am, I took pressure as force by area and
Hmm.
then I used the units to take the dimension.
Yes, the force means mass into acceleration. So we'll take unit of mass and acceleration like that.
Yes, ma'am.
Acceleration means L t to the power 2 minus 2, right? Meter per second square.
Yes, ma'am.
Okay. So yes, so next, can you tell me the dimension of power? Anyone? Dimension of power. This is question number 6.
Ma'am, is it M L cube T minus 3?
M,
L cube T minus 3.
not cube. You can do one let me do it for power. If it will be for power, power means unit time, right?
Voltage into current.
Huh? That is different. That is electrical power. I am telling you about mechanical power. Work per unit time. Like if you say in terms of voltage, also the electric current that we are supplying, or the voltage that we are supplying per unit time, that is the power.
Ma'am,
Yes,
work,
yes, ma'am.
So that is
force and
electrical power.
displacement.
Yes, work is force into displacement. So this can be represented as like work can be represented. So first, let us do for work. Hello, am I audible?
Yes, ma'am.
So first, let us do for work. So for work, what will be this? Force into displacement.
Joule.
So force
Joule.
into not joule. I am telling about dimension analysis.
Yes, sir. Means Joule means Newton meter.
Yes. So force means what? Mass into acceleration, and this will be
Acceleration.
displacement. So mass into acceleration means m, acceleration means L to the power minus 2. Oh, people are coming so late. Okay. Okay, so m L to the power minus 2 into displacement is L, right? So what is this? M L square t to the power minus 2. Okay. Now if we will do for path, it will be just work, that is m L2 t to the power minus 2 and t to the power minus 1 for time. So this will be m L square t to the power minus 3. Okay. So Ryan told me, right? So it was just L cube, not cube, L square. Got it?
Yes, ma'am.
Okay. So let us proceed to the next question now. So we'll go to a few, like 2-3 questions for matrix problems. So do you know about the rank of the matrix? Anyone? Do you
Yes,
need a
ma'am.
5 minutes break? Or should we continue? Anyone? You don't need a break?
Let's continue, Anusha.
Okay, should we continue?
That's for me. Sorry.
Continue. For me also, ma'am. Continue.
Okay, okay.
Sorry, all. Sorry.
Okay, okay. We'll do this question now. So, can anyone tell me what do you know about the rank of the matrix? Like it's already written here, but what is the visualization for that? Like, what do you visualize about rank of the matrix?
So determinant of smallest submatrix should not be equal to 0.
Should not be equal to 0. Like I don't get that.
Means
Like
we have
what
to
do you, I know I want to know the visualization.
means if
How do
we
you solve
find
it?
the rank of this matrix, then we have to find the determinant of matrix. If this is equal to 0, then
Hmm.
we have to check the the submatrix like a square matrix.
Hmm.
And if that is equals to 0, then we have to choose the rank 1 uh, in this way.
Okay. So can you solve this?
So rank equals to 2, I think.
Yeah. Like you have to do first the row and column operations, right?
Yes.
So can you do it for me? Others? I'll solve it for you. For first, I'll give you 2 minutes to solve this, and then we can proceed with the solution. So I'll give you a brief detail of this rank first. So rank of a matrix is the maximum number of linearly independent column or rows of a matrix. And what do you mean by linear independence? A set of vectors that is called linear independent if no vector in the set can linear combination of the other vectors in the system. So by that definition we don't understand anything, right? So let me give you a brief detail like an examples, right? So uh, let us consider like here if we will consider this matrix, this is a 3 by 3 matrix, you know, right? How to represent a matrix, like how many columns and how many rows. Like 3 by 3 means 3
Ma'am,
column, hello, 3 rows and 3
ma'am, ma'am,
columns, right?
rank is 3 here.
Okay, we'll get
No,
on to
ma'am.
that. We'll get on to that. Let's first do like I'll give you a few example for those who don't know what is rank. So like if we consider a vector as 3 and 2 and another vector if we consider as 6 and 4, so can you tell me what does linearly dependent or linearly independent means? How we will understand this n1 and n2 are linearly dependent or independent? What to do?
If there is any relationship between N1 and N2, then it will be linearly dependent.
Linearly dependent. Correct.
Dependent.
Correct. Like if we will like we can see that n1 if we will be multiplying with 2 then we will get n2. That means n2 is equal to twice of n1. Correct. So that means these are not linearly independent. This is linearly dependent. So like if if we take another example is let's suppose 4 0, and n2 is, let's suppose, 0 and 6. So in that case, n1 and n2 we can't relate. Like let's suppose if we will form like coefficients and form an equation of it, out of it, like we are solved in maths, right? In engineering mathematics also, like we can, like matrix are basically polynomial equations, so we are representing it in the form of matrix, like a1 okay, like a1 n1 plus a2 n2 is equal to 0, and b1 n1 plus b2 n2 is equal to 0, right? So this one we can represent it as a1 a2 b1 b2 n1 n2 is equal to 0 0. We can represent it like that, right? So in the same way we can represent n1 and n2 here. So we can consider it as like simple in the matrix form. It will be C1, like let us suppose it is like we want to relate that whether they have any relation or not. So C1 first matrix plus C2 first matrix, sorry, second matrix, and is equal to 0. We will check whether these two metrics are dependent or independent. So if we will do this, if we will solve this equation, then we can see that C1, like there will be two equations like in this way, right? In this A1 B1 form and B1 B2. So this will be like this will be C1 will be one constant like scalar vector, sorry, scalar, and this C2 will be one scalar. So we can represent it in two polynomial equations. So if we will solve that equation, then C1 we will get 0 and C2 will, if we will get 0. So if they are 0, then this will be considered as linearly independent. That means we will check whether these constants are this constant's value are 0 or this constant have some value. If they have some value, then they are dependent, and otherwise they are independent. So okay. Now, if we will see the same way for the first problem, like for this problem, then it will be written as C1 3 2 and plus C2 6 4. Then it will be is equal to 0. We can see that if we will solve this, we can get C1 is equal to twice of minus twice of C2, right? That means C1 plus C2 twice of C2 is equal to 0. That means they are linearly dependent, right? So in this case, if we will solve for this, let me use some other color because it is not detectable. Okay. So if we will solve this, we will get infinite number of solutions for this. So now if we will go for the rank of the matrix, we want what? We want the matrix to be linearly independent. The maximum number of linearly independent rows and columns that are present on the matrix, that is given by that is said to be the rank of the matrix. So now before diving into that, we will know that what is row Euclidean form. Like we will change this matrix into the maximum number of rows or columns we can omit. So we will do row operation first for this. So there are three types of row operations that we can do. First is Ri is some constant of Ri. That means for any row we can multiply all of the what should I say, terms, all of the terms of that row with some specific constant. Type 2 is like a type of row operations. So type 2 will be Ri plus some constant with another row Rj. Like we will multiply the constant with another row, and we will add on that the previous row to that row, so that we can omit the previous row, right? This will be, we will be doing as per our convenience. So this is the most used one. And third is Ri to Rj, like we will just change the rows. So first of all, in this specific like matrix that is given in the question itself, so step 1 that we are taking is R1. See, the second row, we can see that -1 -1 -1, so that will be like very useful for omitting like the first row and the third row. Like we can simplify the matrix as it is. So what we can do is r1 minus 4r2. So if we will do this operation, we can omit the 4 -4. Like we will first consider this -4 into we'll take this into consideration first. We'll try to omit this. So what so that's why we have negated it with 4, so that we can be like we can omit this. So if we will do this, then -4 1 -1 -1 -1 -1, this is the matrix that we have. So we will omit this. So this will become what? This will become 0. And 5 3 -1 -1 -1 and 7 3 1. Anyone is having any problem in understanding? Hello, are you getting my point?
Yes, ma'am.
Okay. So if you will be facing any difficulty, you can like stop me there and you can ask the question. Okay. So next operation that we'll be doing is like we'll be taking row 3 into consideration, and again we'll be using row 2, because row 2 is the like it is most simpler form, so we can use that. So in the same way, we will do r3 tends to r3 plus 7 r2. So if we will do this, we can see r3 plus 7 r2, so 7 gets like becomes 0 again. So if we will do this 0 5 3 -1 -1 -1, and this will be 0, and this will be -10 and -6. Now we need to make this 0, like let me use some different color. We can say this in the simplest form. This is the simplest form now, and this is related to this. These are linearly dependent, these two rows. So we can use row 1 to take out this row 3. So if we will do this operation, r3 tends to r3 plus 2 r1, then what we will do, like what will happen is this will be 0 5 3 -1 -1 -1, and this will become 0. See, 10 and 6. So 5 and 3 will be cancelling that out. So this will be 0 0 0. And if we will take this cannot be further simplified. So there is no way, like it will be remaining as such. So what is the rank? Then there are two linearly independent rows, so rank is 2. Understood? Any question? So answer is B. Any question, anyone, or have you understood?
Understood.
Okay. Then let us proceed to the next question. Now what we will do, we'll find the determinant of A inverse. Can you find that out? Okay, I think it will take at least 2 minutes to solve this. I'll give you 2 minutes and I'll be coming back in 2 minutes. Yeah, tell me.
1/4.
1/4. Yes, it will be 1/4. Okay, if okay, we'll wait for someone else to answer. Okay, I'll give you 2 minutes for others to solve this.
Yes, ma'am, 1/4.
Then if 2 have answered, so we should proceed to the solution. So determinant of A inverse is equal to 1 upon determinant of A. So determinant of A, we know like how to find out, like if there is A1, A11, A12, A13, A14, then this matrix, this determinant will be A11, A14 minus A12, A13. This we already know, all know, right? So determinant of A will be what? This will be 1, determinant of 4, 5, 0, 1 plus 2, determinant of 0, 5, 0, 1 and plus 3, determinant of 0, 4, 0, 0. So if we will like solve this, this will be 1, this will be 1, 4 into 1 plus 5 into 0, that means 4, and this will be, both of them will be 0. So this is 4. That means determinant of A inverse is equal to 1 upon 4. That means option D. Any question? They are simple mathematics, nothing else. Okay. Then let us proceed to the next question. So next question tells me what is the lowest eigenvalue of the matrix. Okay. This is question number 9. So the matrix is 4, 2, 1, 3. So what is the lowest eigenvalue for this? So do you know what is the eigenvalue? Eigenvalue, like as I've already told you, the matrices we can represent in the form of what? In the form of like polynomials. So basically polynomials we are representing
And
for
2.
solving the polynomials. Yeah, correct.
Okay.
So for solving the polynomials, we are representing that in the form of matrices. So the roots of that polynomials is called the eigenvalue of the matrix. Okay. So, okay. So how should we find out the eigenvalue of the matrix? Anyone else? Okay. I think we should go for it. So we have already done that in engineering mathematics. This is lambda I is equal to 0. So this is given as 4, 2, 1, 3. This is the matrix minus lambda. This I is the identity matrix, that is 1, 0, 0, 1. So 1, 0, 0, 1 is equal to 0. So this will be 4 minus lambda 0, 0, sorry, not 0, 0, this will be 2 and 1. So this will be 3 minus lambda, this will be 0. So this is 4 minus lambda, 3 minus lambda minus 2, this is 0. So if we will solve this, this is lambda square minus 7 lambda plus 10 is equal to 0. So lambda will be 5 and 2. So the minimum eigenvalue is 2. So answer is A. Okay, let's proceed to the next question now. So again, we are diving into the fluid mechanics questions. So we have, sir have already told you how to find out the stress factors. Like we have already done that derivation, right? Hello.
Yes, ma'am.
So can you solve this if I'll give you the question? Like this is the first
We'll
question.
try, ma'am.
Yes. So try and solve this, then I'll explain it to you. I'll give a 5 minutes to solve the first question. So consider the two-dimensional stress field as shown. So this is the object that over which that is our body into consideration, and the plane AA, that AA plane is cutting through the element at a 30-degree angle as shown. So determine the magnitude of shear stress acting on the plane AA. What is the magnitude of shear stress? So they have also given that tau xx. You know that tau can also be represented as sigma, right? So tau xx is given as 3000 Newton per meter square. Yy is given as 2000 and xy is given as 500. So I think you can calculate the magnitude of shear stress that is applied on plane A. So what is the shear stress that is applied here? Can you tell me? Okay, so I'll give you 5 minutes first. You solve this and then I'll proceed with the solution. You can try at least, because it is simple, like the derivation you have already done in class. So like the same way I have shown you the derivation today, the same way this will be done. So that derivation, based on that derivation, you will first do the derivation, you will get some equation, and based on that equation, you will get the shear stress that is acting on plane A. Like what you will do, like sir have solved one triangular form, right? So you got the Cauchy's theorem from that. That means what we will do, the plane that we need, we will just take its component in all the directions, and that component will sum that up. And if we already know all the components of shear stress, so we'll just sum that up, take the values of the angle, depending upon that, we'll just take the component and sum that up, so we'll get the value. Understood? Do that. Try. Okay, I'll give you 5 minutes. I'll be back in 5 minutes. So have you solved it? Anyone?
683.
2683, right?
No, ma'am, 683.
Oh, sorry. Yes, 683. Yeah, correct. So let me solve that for you. So we need to take into consideration the section that is denoted by A, right? So this is the section, right? So this this angle is 30 degree. So if this is taken as L, this length is given already, I guess. Just 1 second. Yeah. So okay. So this L we don't need. Let me do it for you. So this L, if we will divide this component into the horizontal and the vertical distance, so this is L cos theta. Theta means 30 degree, and this is L sin theta. That means 30 degree. So this is tau AA, that is the stress in this like direction. So this we need to find out, and this is the shear stress, and this is the normal stress. So normal stress is given by AA. So okay, so this direction, that is what is given, tau axis is given. So tau axis is given as 3000. So sorry, sigma xx. Sigma xx, that is the shear stress in xx direction, that is tau xx. We can denote anywhere, anyhow we want. We can denote it even like tau. So tau axis is given as 3000, and this direction is tau yy. Tau yy is given as 2000, and another is tau xy. Tau xy means just 1 second. This is x and this is y. So tau x on this surface, yeah, tau xy we cannot obtain, like here I cannot show. So I'll just now write the total force. Total summation of force here will be is equal to 0, obviously. So this will be the total summation of force. How we can write? Tau AA. Tau AA is on this surface, the shear stress that is acting on this surface. So the shear stress multiplied by L, this we need to find out, minus the total shear stress that is applied on here, and the perpendicular, like the perpendicular normal stress, is equal to, just 1 second. Yeah, so this is equal to 3000. This component in AA direction, that means this is the component in this direction, that is cos 30 degree. So this is 3000 cos 30 degree, minus this is 500 sin 30 degree. So this is 500 and this is 500 in this direction, and 500 means sigma xy, right? So sigma xy 500 in sin 30 degree, right? So yeah, so this whole multiplied by L sin 30, that means this is the area where this is acting. So this is the area where this is acting, and we are taking its component in this direction. So the area that is where it is acting is, see, this is tau xx in this direction, and yes, sorry, so tau xy will be in this direction. Let me use some other color. Yeah, tau xy in will be uh, tau xy will be in this direction, in that surface, right? Tau xy. So it will be 500. That's why it is sine 30 degree and it is minus, right? Because it is just in the opposite direction. Yeah. So the distance is sorry, the area of the surface. We are taking unity in the z direction. Someone has unmuted yourself. You want to say something? Okay. So the
Sorry,
area is, yes. Okay. No problem.
Sorry.
So the area is L sine 30. L sine 30 is this direction where this both of these forces are acting, like shear stresses are acting. Shear stress multiplied by area will be the force, as I've already told you in the derivation. So the area is L sine 30 this direction, and where it is acting, and multiplied by 1. If we are taking that perpendicular the paper or the screen, we are taking it at 1 as 1. So this is multiplied by 1. So in the similar way, for the surface, this horizontal surface, will be taking this as 500 cos 30 degree minus 2000. That means this is 2000, right? Y by 2000, but we need to take it to this direction, right? So if we will take it to this direction, it will be sine 30 degree. So multiplied by the area over which it is acting is L cos 30 degree. So one second, tau xy is in this is yx, right? That means tau yx is in this direction, and as we know from Cauchy's theorem, yx is equal to tau xy. So we can put the same value over here. So here we have written like that. So therefore, if we will solve this, we can get tau AA to be 683 Newton per meter square. Okay. Anyone is having any doubt? Any doubt that you are not able to understand?
Sir, ma'am, we have two equation or one equation?
Two equations, one equation, na? We will balance the force is equal to mass into acceleration. Here the body is at rest, so acceleration will be 0. So that's why summation of forces will be equal to 0. So this is one equation, right? So we are just multiplying all the forces. Like forces means what? Stress into area. So we are just multiplying the same, the derivation what I have already shown you. Same way. Understood?
Yes, ma'am, understood.
So should I proceed to the next question? I think I'll do up to next question only. The we are left with the other two questions that I'll be solving in the next class. So because it's already 8:45. Okay. So let me proceed to the next question. Yeah. So determine the magnitude of normal stress acting on plane AA. Now we have understood the shear stress that is acting on plane AA. That means we have applied all the force balance, and we have taken out the shear stress. That is, if this is the formula, so let me use some color. So this we have found out, right? Now we need to find out this, the perpendicular stresses. So will you be able to find out that? Like this is a similar way, right? Similar way you have to find out for the perpendicular stress. So can anyone do that?
A, ma'am.
Yeah, anyone else? I won't tell you the right answer. So first you solve, then I'll tell you the right answer. I'll give you 5 minutes. I'm here only. If you are having any problem, you tell me. Just the way we have taken the horizontal, like uh, this is the plane AA. So whatever components we have taken for the tau xx, tau xy, and tau yy, we have taken in this like horizontal direction for shear stress, right? In not horizontal, I'll tell you in this direction, right? Because the shear stress is acting in this direction, downwards rather. So for like you can see the diagram, right? Let me show you the diagram. Yeah, this one. So we need to find out for pressure now. So we will take the vertical component, like for this surface, the vertical to the surface. So this pressure we need to calculate now, the pressure stress, like the normal stress rather. Pressure is the wrong word. Normal stress to the surface. Uh, the same way we have to just take the component in that direction, nothing else. Simple mechanics.
Option A.
Option A. Okay. Anyone else? Anyone else? Is there no one present here? Are you not able to solve this? I've already shown you the previous question. In the similar way, this will be solved. Okay. So I think we should solve this. Okay. Let's solve this now. So this is question number 9. So if we will draw take this diagram into consideration. So yeah. So first we will consider tau xx. Right. So tau xx is 3000, and it will be considered in this direction, that is in the normal direction to the surface A. Right. So first we will balance all the forces. So this will be similar way L. So this is the force on this surface AA, right? So this plus, sorry, minus, so 3000, like this one, if we will be taking the vertical component of this 3000, so it will be in this direction, but we want in this direction. So if we will want in this direction, so we'll just take the minus sign of that, right? So this will be minus 3000. Okay, the class will just end. I don't know, like you have joined now, so yeah, it's fine. So this will be the sine component of that, of the tau xx, plus 5000, sorry, 500. That means the tau xy on the surface, on this surface, on the on which surface, on this surface, tau xx, sorry, xx on this surface, and tau xy on this surface. So tau xy is in downward direction, right? So you'll also take the minus sign of this, because the stress that we need is tau aa, that is in this direction. We are taking, cos tau a is our point of consideration, so we will take everything in that direction, right? Like we are taking in the vertical direction for that. So 500, so its vertical component will be cos 30 degree. So everything will be like again it will be L sine 30 degree. So cause the area of that is this only, this into unity. Okay, so in the similar way, for this surface we'll do, wait one second. So fill this surface, for this surface we'll do for the horizontal surface, and for the horizontal surface we have tau yy and tau yx, and tau yx is equal to tau xy, so we can write in the same way. So this will be 2000 cos 30 degree plus 500 sine 30 degree. So this will be L cos 30 degree. L cos 30 degree multiplied by 1 will be the surface area. So if we will do this, this will be 2683 Newton per meter square. So this means option A. Anyone is having any problem in understanding? Have you understood? Similar way, like the previous question we have done na, in the similar way. Just here we will take the vertical components. Have you understood? And mine did vertical to the surface AA, like plane AA. Because what we need this one. Just one second. We need this sigma AA, that, or we can even represent as tau AA. So this is our point of consideration. So because of that, we are taking everything on that direction. And when we did for shear stress, so we took everything in that direction, tau AA direction, right? Okay, so if anyone is not having any problem, so I think we should end today's class. There are two more questions left, like that is connected to this question as it is. So I think we'll solve that on the next class. Okay. So anyone is having any problem, or should I communicate, like this was an interactive session, so you enjoyed the class, right?
Yes, ma'am.
Okay, so so in the similar fashion we will do the next classes. So attend that so that you can get a clear idea of all the questions. So this will also enhance your problem solving, because sir will taught in class everything, like sir will teach in class, that is basically the derivation portion and the theoretical purpose. So we are here for solving the problems for you, so that you will do the assignment, so it will be easier for you to do the class assignment. So that's why we are doing some extra problems for that case. Okay, so I'll bid you farewell today. I'll meet you on the same time next week. Okay, bye.
Excuse me, ma'am.
Yeah, tell me.
Uh, can I ask one doubt?
Yes, please.
Can you give me one example of microscopic approach?
Microscopic approach, like as I told you, in case of like microscale processes that we do, like in case of like nanoscale, like some channel is there and cells are passing through that, so each and every cell you need to track on that purpose. So and in that case you need to see whether all the cells are like I have shown you that channel, right? Because of centrifugal force the heavier particles will drift apart, like drift on the sides. And yeah, so that is the like microscopic approach. So for each and every particles you need to track in that case. So is it clear?
Means is there any device name is physical device? Can you
No, no, no,
suggest
no.
me?
It's just like what we do is that we take microscopic images, right? And based on that image, we'll like. Let me give you one more example. Have you heard about electrodeposition?
Yes.
Tell me what is it?
Means uh, like anode and cathode ray. Sorry, anode and cathode. Na, means two terminal if we
Pardon? Unable
in
to understand.
uh, means like positive ions will be deposited on means
See, it will
cathode.
be just there'll be one solution. So it will be just taking one electron from the electricity that will be passing. So it will take electron and will be deposited. Right. This is simply
Yes.
simple electrodeposition.
Yes.
So we will supply the basic concept is we will supply some electrical energy rather, and that electrical energy means what? Means electrons will be passing. So when electrons will be passing, the ions, positive ions that is present in the solution will take the electron and will be deposited as matrix. Simple. So when electrodeposition will take place, right, there will be very small section and all of the particles will be deposited there, right? So you will be taking images and you will be thinking that the particles, that is like you can't track all of the whole place, right? So you will take one small area and you will assume that the particles that is deposited on that area will be excuse me, will be covering the particles of the whole place, like whole electrode rather. You understood, right? Like
Oh
in case
yes.
of we will be like in case of ITO coated glass, we also use that in electrodeposition, so that the like copper is deposited on that glass. So if copper is deposited on that glass on all the places, so how many particles are deposited? We'll take one small zone, and that is a microscopic approach, cause we take the image of that zone, and in that image there will be many particles present. So we will track all the particles, how many numbers of particles are there, correct? So we are tracking individual particles over there. So that is a
Okay, ma'am.
microscopic approach. And the
Okay,
cell
ma'am.
also, that is also microscopic approach. So because we are tracking individual particles, because I told you now, when you will go to microscopic scale, there will be many other forces that will be coming to, like one force that is very important is capillary force. Have you heard about it?
Uh,
Capillary force or surface tension
I,
force.
I know capillary action, capillary force. I don't.
Okay, so um, give you a demonstration. I have a paper here. Just 1 second. So this is a simple filter paper, right? So if I'll give a drop over here, see, is it visible? The drop that I have given in the middle, it's visible, right? So it will be
Yes.
drifting in all direction. How? I have not provided any pressure, right? How then it is drifting in all direction? Its tendency will be to drift in the all the direction equally. Cause see, a circle is formed. You can see it, right?
Yes.
So what is happening? The drop that I am giving in the middle, the capillary force in all the direction is same. Cause see, you are seeing it as a paper, but it is basically microfibers are inside. So there are numerous microcapillaries inside. Capillary means you have in your school, have you read about the capillary? That is one like in water there will be the capillary will be depressed, and in mercury it will be traveling like if there is a beaker and we will be dipping one capillary over there. So in case of water, the capillary meniscus will be lower than the outer layer, and in mercury it will be upwards.
Yes.
Have you seen that? Have you done
Yes,
the
ma'am.
experiment anytime? Yes. So that is capillary pressure. So uh, there will be a suction force that will be generated in between uh, have you heard about adhesive and cohesive force?
Yes, ma'am.
Yes. So adhesive force is the attractive force between the unlike molecules, and cohesive force is between the like molecules. So what is happening in simple terms is that the paper, like in case of paper or in the glass capillary, if you can say. So what is happening? Glass, there are numerous hydroxyl bonds in the glass. So that hydroxyl bond will be we know water is polar, so it will be sucking, like it will be creating a negative gradient, pressure gradient over there. So what will be happening is that there is the bond forming between water and the capillary, like glass capillary, like that the glass particles are so strong that the cohesive force between the like molecules, that is the water and water, won't
Yes.
be able to keep it on place. It will be moving in the capillary. So that is the capillary pressure. So
Yes, understood.
in simple terms, in paper also we are seeing this capillary pressure. That's why numerous devices, paper based paper based microfluidic devices is also applicable. So in that simple phenomena, this is what is happening. So have you understood? Is your doubt clear?
Yes, yes, ma'am. Yeah.
So I just want to be interactive and to explain in simple terms so that you can get an idea of what is happening. So if you anytime get interested in research, so you can do that as well. Any other question?
No, ma'am.
Okay, should I end the class?
Yes, ma'am. Thank
Okay, thank you everyone. Bye bye, meet you in next class.
you. Bye-bye.
Thank you, ma'am.
Thank you, man.